System Professor, Department of Physics. In this video, I am going to explain about the lasers. Okay, lasers and types of quantum processes in laser, right? Okay, so laser is nothing but, so this is the light wave. The application is light amplification by stimulated emission of radiation. Okay, so laser is nothing but, so this is the light wave. The expansion of laser is light amplification by stimulated emission of radiation. So here the main principle is stimulated emission. So this is the one of the quantum processes in light. Okay, so laser is the one of the light wave. So compared to ordinary light wave, so it has much unique properties. So these are highly directional, high intensity, highly coherent, and highly monochromatic. Okay, so these are the light waves. So it has, compared to ordinary light wave, it has some unique properties. So it has highly directional in the sense it has moved in the single direction. Okay, so it doesn't diverge. So compared to ordinary light wave, it doesn't diverge. So it moves in the straight line. Okay, so it has highly directional and high intensity. So the intensity of the wave is very high and it is highly coherent. Coherent in the sense the emitted waves in the laser arc, so all has same amplitude and same wavelength and the same phase. So all the laser light emitted from laser all has same amplitude, same phase and the same frequency. So that is called as coherent. So our laser source are highly coherent waves, right? Okay. So this one is highly monochromatic. So monochromatic in the sense, so it will emit only single wavelength of light. Okay, compared to ordinary light source. So ordinary light source will emit the multiple wavelengths. Okay, that's not a monochromatic source. That will be a polychromatic source. Okay. So now the laser is the single. So it will emit the single wavelength of light. So it is called as highly monochromatic. Okay. So compared to ordinary light, so it has these three properties. So these four properties: highly directional, highly intensity, highly coherent, and highly monochromatic. Okay. So the main condition of laser is stimulated emission. So okay, the main condition is stimulated emission. Okay. So now the atomic system is exposed in the light radiation. So what will happen means, so it will produce the three quantum processes. The first process is stimulated absorption. So the second quantum process is spontaneous emission. The third process is stimulated emission. Okay, so now the light radiation is incident on the atomic system. So it will involve the three quantum processes. So stimulated absorption, spontaneous emission, and stimulated emission. So we have three quantum processes. So stimulated absorption. So let us consider the two energy levels. So two energy level E1 and E2. So this is ground state. This one is excited state. So we have two energy level, ground state and excited state, E1 and E2. Okay. So now normally atoms are present at only ground state. Okay. So let us consider the ground state. It has all the atoms are arranged at only ground state. Okay. So the number of atoms in ground state will be N1. The number of atoms in excited state will be N2. Okay. So now let us consider two energy level E1 and E2. So now the atoms are present at only ground state, right? So here the number of atoms in the ground state will be N1. Number of atoms in excited state will be N2. Okay. So always N1 will be greater than the N2. Okay. So N1 is nothing but the ground state atoms. Okay. Ground state atoms excited to the excited state. Okay. So now the ground state molecules will absorb the HU of energy of photon. Then it absorbs the energy and goes to higher energy level. So this is called as stimulated absorption. Okay. So after the we stimulate the ground state atoms with the HU of energy of photon. Then it absorbs the energy and goes to higher energy level. This is called as stimulated absorption. So now E1 plus HNU is equal to H. So E1 plus HNU is equal to E2. Okay. So now E2 minus E1